Okay, let's have a look at this union and the addition rule when we have to answer a question where they ask us for the probability of the union. So when they ask us, and they'll usually write that your textbook uses PR, I tend to just use P, either of those are acceptable. When you end up with P, do B. So they want to know the probability of the union between A and B. Now we know union, this section in here, this is the intersection. We don't want the intersection, we want the union. So we want all of A and all of B grouped together. Now what I want you to notice, and I know that I'm talking about Venn diagrams here, but Venn diagrams and tables are actually displaying the same information. So I want to make that link. If I take all of the probability of A, you can see that it includes this shaded region. So regardless of what that probability is, if I take the whole probability of A, this region is included. If I take the whole of the probability of B, this region is also included in that probability. This means that if I take all of the probability of A and add all of the probability of B, that I've counted this middle section twice, because I've counted it once in the probability of A and once in the probability of B. So the addition rule of probability says that if I want the probability of the union between A and B, I need to have the probability of A, add the probability of B, and then I've got to take away the probability that's in the middle, the crossover. Now we know that's the intersection, so I've got to take away the probability of the intersection between A and B, because I counted it twice. And we can see the same thing when we look at our table. So if I'm talking about the total probability of A, we would find that here. This would be the probability of A. And of course this part here would be the total probability of not A. This part here, if I go to the bottom of that column, this would be the probability of B. And this is of course the total probability, which would always be 1, or the total number of things that were in that set, in the universal set. But notice that if I take this whole column and this whole row, I've actually counted this square twice, because it's used in the total for this column and it's also used in the total for this row. And that there is actually the intersection between A and B. So these two regions represent the same thing. So that's how we get the addition rule. So whenever you're working with these problems, you will need to either draw yourself a table or some other diagram in order to work out where everything fits, because most often they won't give you all the information you need, and you'll see that in examples, I think it's 19 and 20 from your textbook. So I hope that that helps explain the addition rule, and that will help you understand how they got those answers to the questions.